Look up at the night sky. For thousands of years, humans have looked up and seen the same familiar sight, a glowing sphere quietly orbiting our planet. The moon has inspired myths, guided explorers, influenced tides, and even shaped life on Earth. But have you ever wondered what would happen if the moon suddenly disappeared? Not moved farther away, not destroyed slowly, but vanished instantly. It might sound like something from a science fiction movie, but the consequences would be far more serious than most people imagine. Let's explore what would actually happen if the moon disappeared. First, the most immediate change would happen in Earth's oceans. The moon's gravity is the primary force orchestrating the rhythm of our oceans. Every day, its relentless gravitational pull tugs at the water, causing it to bulge outwards on the side of Earth facing the moon, and also on the side opposite. As our planet rotates through these bulges, coastlines around the world experience the familiar rise and fall of the tides. The sun also exerts a gravitational pull, but because it's so much farther away, its effect is less than half that of the moon. When the sun and moon align, their forces combine to create exceptionally high and low spring tides. When they are at right angles, they work against each other, resulting in the much weaker neap tides. Without the moon, this powerful, complex dance would cease. The grand spectacle of the tides would almost completely disappear. The sun's gravity would still create small, weak tides, but they would only be about 1/3 as strong as the lunar tides we experience today. The twice-daily pulse of the ocean would fade into a faint, almost imperceptible whisper. This might not seem like a big deal, but the consequences of losing our tides would be catastrophic, starting with the delicate ecosystems that depend on them. Tides are the lifeblood of coastal environments. They drive the circulation in estuaries, mixing fresh river water with salty ocean water to create unique habitats that serve as critical nurseries for countless fish species. This mixing process is also vital for flushing out pollutants and distributing nutrients, which supports immense biological productivity. Without the strong tidal currents, these estuaries would stagnate. Salinity levels would change drastically, and the flow of nutrients would halt, devastating the fisheries and coastal economies that rely on these vibrant ecosystems. The intertidal zone, that precious strip of land where the sea and shore meet, is one of the most dynamic environments on Earth, and it exists entirely because of the tides. Many sea creatures, from barnacles and mussels to crabs and starfish, have adapted their entire life cycles to this daily rhythm of submersion and exposure. They rely on the tides for feeding, for breeding, and for protection from predators. At low tide, these areas become a crucial feeding ground for shorebirds. If the tides disappeared, these rich, biodiverse zones would vanish. The constant water level would create a static, impoverished coastline, and entire ecosystems built over millennia on the reliable pulse of the ocean could collapse. Next comes something even more dramatic: Earth's stability. The moon acts like a stabilizing weight for our planet. Its gravity helps keep Earth's axis tilted at a relatively stable angle of about 23.5 degrees. That tilt is the reason we have seasons. Without the moon, Earth's tilt could begin to wobble wildly over time. Scientists believe the planet's axis could shift anywhere between 0 and 45 degrees. This means the climate on Earth could change drastically. Some regions could experience extreme winters lasting months, while others could face scorching heat almost year-round. Weather patterns would become unpredictable, and many ecosystems would struggle to adapt. But the moon doesn't just affect our oceans and climate. It also slows down Earth's rotation. Every year, the gravitational interaction between Earth and the moon slightly slows our planet's spin. Over millions of years, this process has lengthened Earth's days. Hundreds of millions of years ago, a single day on Earth lasted only about 18 hours. Without the moon, this slowing process would stop. Days would remain the same length for a long time, but over geological timescales, Earth's rotation might behave very differently. Now let's talk about the nights. Imagine a world where every night is a new moon night, plunged into an abyss of profound darkness. Without the moon, our nighttime would become significantly, almost unimaginably darker. The familiar silvery glow that bathes our world would be gone forever, leaving only the distant cold pinpricks of stars and planets to light the way. The full moon, after all, is a colossal mirror, reflecting sunlight back to Earth. On a clear night, it can be over 400 times brighter than a sky lit only by starlight, transforming familiar landscapes, oceans, and forests into ethereal, monochrome versions of themselves. For millennia, life has adapted to this lunar rhythm. Many animals rely on moonlight to hunt, navigate, or avoid predators. Owls and large cats use its faint illumination to spot the subtlest movements of their prey. Newly hatched sea turtles follow its reflection on the waves to find their way to the ocean. If the moon disappeared, the night sky would be dominated only by the brilliant tapestry of stars and planets. For astronomers, this would be a golden age, revealing the cosmos in unprecedented clarity, free from the moon's powerful glare. But for life on Earth, the consequences would be immediate and chaotic. This sudden, perpetual darkness could disrupt the delicate balance of countless nocturnal ecosystems. Predators that rely on moonlight to hunt would struggle, facing starvation. Conversely, prey animals that hide in darkness might suddenly gain an overwhelming advantage, their populations booming. Over time, this fundamental shift could trigger a cascade of extinctions and alter the very structure of life as we know it. And it's not just animals. For thousands of years, humans have used the moon to navigate the seas, to mark the passage of time with lunar calendars, and to inspire art, mythology, and religion. In our modern world, the predictable cycle of bright nights and dark nights even influences how we design and manage our power grids for nighttime lighting. A world without the moon wouldn't just be darker, it would be a profoundly different and less predictable place. Another surprising effect would involve Earth's oceans and currents. Tides help mix ocean waters, distributing heat, oxygen, and nutrients throughout the seas. Without strong tides, this mixing process would weaken. That could affect ocean circulation patterns and potentially change the global climate. We look out at the cosmos and wonder if we are alone. We search for planets with the right ingredients for life. Liquid water, a stable star, a protective atmosphere. But what if one of the most crucial ingredients for life on Earth wasn't on our planet at all, but orbiting it? Beyond its gravitational dance and its command of our tides, perhaps the most profound question we can ask is this: how essential was the moon for the evolution of life itself? The answer, many scientists now believe, is that it was absolutely fundamental. To understand why, we must travel back in time over 4 billion years to a young, volatile Earth. The moon was much closer then, a colossal presence in the sky, exerting a gravitational pull hundreds of times stronger than today. This created immense, powerful tides that swept across the planet's barren coastlines, not as gentle waves, but as towering walls of water. These tides formed countless shallow pools along the shorelines, primordial laboratories for the chemistry of life. One of the leading hypotheses for the origin of life centers on these very pools. The relentless cycle of flooding and evaporation was key. Each tide would wash in a soup of simple organic compounds from volcanic vents and meteorites. Then, as the sun baked the pool, the water would evaporate, concentrating these chemicals together. This forced proximity, it's theorized, encouraged them to link up, forming longer, more complex chains, the very polymers that are the building blocks of proteins and nucleic acids like RNA. With every new tide, the cycle repeated, a planetary-scale engine churning out the fundamental components of life. But the moon's contribution didn't stop there. It also acted as Earth's cosmic anchor, stabilizing our planet's axial tilt. Without the moon's steadying influence, Earth would be subject to wild, chaotic swings in its tilt over millions of years. Our poles could wander to where the equator is now, and vice versa. This would create extreme and unpredictable climate shifts, with catastrophic ice ages and scorching heat waves, making it nearly impossible for complex, multicellular life to gain a foothold and evolve. The stable, predictable seasons we experience are a direct gift of the moon's gravitational grip. This climatic stability allowed ecosystems to flourish over geological timescales, paving the way for the incredible biodiversity we see today. So when you look up at that familiar silver disk, remember that you may be looking at the silent partner in our planet's story, the celestial midwife that helped nurture the first spark of life and then protected it, allowing it to blossom into the complex world we call home. But could the moon actually disappear? In reality, that's extremely unlikely. The moon formed about 4.5 billion years ago after a massive collision between Earth and a Mars-sized object. Since then, it has been slowly drifting away from Earth at a rate of about 3.8 centimeters per year. Over billions of years, it will continue moving farther away, but it won't suddenly vanish. Still, imagining a world without the moon helps us understand just how important it is. It controls our tides, it stabilizes our planet, it influences our climate, and it lights up our night sky. So the next time you see the moon rising above the horizon, remember this. That glowing object in the sky isn't just beautiful, it's one of the reasons life on Earth exists at all.